All right, welcome back. Day 3 of our 50 Days of AWS challenge. Today, we're getting into something that's, well, it's the absolute bedrock of your cloud network. I'm talking about subnets. And let me tell you, if you get this right, you're set up for success. Security, scalability, the whole deal. But if you get it wrong, oh, you are building on quicksand. So let's make sure we do this the right way.
Okay, so let's start with a scenario. Picture this. Your production app is humming along, everything's green, customers are happy, life is good. And then, bam, one tiny little configuration change and your entire network just goes dark. What do you think is one of the quickest ways to trigger that kind of complete, catastrophic meltdown?
You ready for this? It's a single, overlapping IP address range. That's it. It sounds so small, so innocent, right? But what it does is unleash total chaos on your network routing. Suddenly, nothing can talk to anything else. And this, right here, is exactly the disaster that proper subnetting is designed to stop in its tracks. And that brings us to the first huge takeaway. When we talk about planning your CIDR blocks, look, this isn't just some best practice you can read about and forget. It is absolutely non-negotiable. If you're building anything serious in the cloud, you have to get this right. Seriously, getting it wrong is like pouring a cracked foundation for a skyscraper. It's not a question of if it's going to collapse, it's a question of when.
Okay, so to make sure our foundations are solid, let's really get into the weeds. We need to deconstruct this thing. What is a subnet, really? Like, what's going on under the hood? So you'll hear the official term, a logical subdivision of your VPC. Kinda dry, right? Let's make it simpler. Imagine your VPC is this huge, empty plot of land you own in the cloud. A subnet is you taking out a map and drawing lines on it, saying, okay, this section here is for the house, this part over here is for the garden, and this part way in the back is for the workshop. Each of those sections, each subnet, gets its own unique address range. It's all about organization and, crucially, isolation.
And here's what that looks like in the real world, right in the AWS console. See this? We've got one big VPC, but it's carved up into 7 different subnets. Now look closely at that column labeled IPv4 CIDR. You see it? Every single one of those address ranges is totally unique. There's absolutely no overlap. This is what a healthy, well-planned network looks like. Traffic knows exactly where it's supposed to go, no confusion. All right, so that's the 10,000-foot view. Now let's grab a magnifying glass and zoom way in on just one of these to see what's actually inside. Okay, here are the nitty-gritty details for a subnet we've called Nautilus Subnet. And at first glance, it just looks like a bunch of labels and values, right? But trust me, every single line item here is telling you something critical about how this subnet lives and breathes in your network. Let's break down the really important bits. First, you've got the CIDR block. That's its address space. In this case, it's a /20, which gives us just over 4,000 IP addresses to play with. That's a lot, but here's the thing. Probably the most important field on this screen is the availability zone. See that? US East 1A? That is not just some random label. That tells you this subnet physically exists in one specific data center. And grasping that one concept, that is the key to building resilient, high-availability apps. And yeah, state available just means it's ready to go. Okay, so we've put one subnet under the microscope. But let's be real, in a production environment, you're never going to have just one. So let's zoom back out and talk about architecture. How do you actually use these things to build something real? One of the most common and, frankly, powerful patterns you'll see is a classic 2-tier web architecture. Here's how it works. You create one subnet, let's call it the public subnet, and you put everything that needs to talk to the scary open internet in there, your web servers, your load balancers. Then you create a second, totally separate private subnet. This is where you put the crown jewels, your databases, your sensitive backend services. That private subnet has no direct path to the internet. It's walled off. And those subnets, they are literally the walls you're building to protect your most important assets. All right, now that we're thinking like architects, let's switch gears a little bit. I want to talk about the pitfalls, the common traps that, believe me, even seasoned engineers can stumble into. And getting these wrong, well, it can really hurt. Number 1, the absolute cardinal sin. CIDR overlap. I know, I sound like a broken record, but it is that important. Just don't do it, ever. Number 2, ignoring availability zones. This is a big one. If you stack all your subnets into, say, US East 1A, and that one data center has a bad day, guess what? Your entire app is gone. Poof! You've just created a massive single point of failure. And finally, just poor planning for the future. You always want to give yourself more IP address space than you think you'll need right now. Because your company will grow, your app will grow, and trust me, running out of IP addresses is a nightmare scenario you do not want to deal with. Okay, enough theory. Let's make this interesting. I'm going to throw a few questions at you that are pretty common in cloud engineering interviews. Think of it as a little pop quiz. Let's see if you can beat me to the answer. Okay, question number 1. You just spun up a brand new subnet. You launch an EC2 instance inside it. You SSH in, you type ping google.com, and you get nothing. Crickets. It's completely cut off from the world. What's the most likely thing you forgot to configure?
Did you get it? The answer is the route table. A new subnet by default is like a room with no doors. It has no idea how to get anywhere. You have to go into its associated route table and add a rule, a little signpost that basically says, hey, for any traffic trying to get to the internet, send it that way and point it to an internet gateway.
All right, question 2. We've talked about this already, but it's so important I want to ask it directly. Why is it an absolute best practice to build your production application with subnets spread across multiple availability zones?
It all comes down to one thing: high availability. You have to remember, availability zones are not just logical labels. They are physically separate buildings, sometimes miles apart, with their own power, their own cooling, their own networking. So if one of them has a catastrophic failure, I'm talking fire, flood, power grid failure, your application doesn't die. It can just fail over and keep running on the resources you have in the other perfectly healthy AZs. It is your .1 insurance policy against disaster.
Last one. This one's a bit more technical, so listen close. Your VPC has a CIDR of 10.0.0.0/16. Now, can you create 2 subnets? One with the CIDR 10.0.1.0/24 and a second one with 10.0.1.128/25. Yes or no, and why? The answer is a hard no. You absolutely cannot do that. Why? Because the first range, that /24, covers all the IP addresses from 10.0.1.0 all the way up to 10.0.1.255. The second range you want to create starts at .128. Well, .128 is sitting right smack in the middle of that first range. That is a textbook CIDR overlap, and AWS will flat out reject it. It won't even let you create it. So look, if you take away one thing from all this, let it be this. Subnets are not just boring little containers for IP addresses. That's not what they are. They are the Lego blocks. They are the foundational pieces you use to architect everything: your security posture, your plans for scalability, and your app's ability to survive when things go wrong. And that really just leaves us with one final question to think about. The next time you go into the console to create a new VPC, please don't just click Next, Next, Finish and accept the defaults. Stop for a minute. Think about what you're actually building and ask yourself, how can I design these subnets not just for what I need today, but to be ready for where this application is going to be a year or even 5 years from now?